So these properties of determinant useful to reduce the time of calculations. So first property. So first property says, so you keep these properties in the mind when we will study the matrices. You want to comparatively you want to study the matrix with determinant. So when we will compare the determinant with matrix, these properties are required. What is the change? What is the similarity in the properties of determinant and matrices? So for to study that similarity and differences, these properties you want to keep in the mind. Again, this is economical tool to reduce the time of calculation, that is to increase the speed of calculations, which is very much useful for JEE, CET competitive exams and also in engineering. So first property, interchanging rows and columns of determinant its value not changed. So what is happening in the matrix at that time we will study and we will compare this. So suppose for example, what this property says, so if we change rows into columns and columns into rows, the value of determinant is not changed, remains same. So very simple, we will consider for comparison 2 by 2 determinant. So D is equal to, suppose we will consider 2, 3, 4, 5. Now if we evaluate this determinant, we will get 2 into 5 minus 4 into 3. So that is equal to 10 minus 12, so minus 2. So that is the value of the determinant is minus 2. Now interchanging rows and columns, in this lecture we will study very important article in determinant, properties of determinants. By applying the properties of the determinant, the time of calculation of the value of determinant is reduced. Also these properties are useful to compare determinant with matrices. So first property, interchanging rows and columns of determinant, its value not changed. So if we write rows as a columns and columns as a rows, value is not changed. So for example, suppose D is equal, we consider 2, 3, 4, 5. So if we expand this, so 2 into 5 minus 4 into 3. So that is coming 10 minus 12, so minus 2. Now interchanging rows and columns, suppose we get the determinant D dash. So 2, 4, 3, 5, that is equal to 2 into 5 minus 3 into 4. So that is coming 10 minus 12 again minus. So the value of given determinant and the value of the determinant obtained by interchanging rows and columns coming same. So therefore D is equal to D dash. So this is the proof of this verification of the first property. Now second property, if we interchange any two rows or columns, value of determinant changes by sign. So positive value will get negative value. So same example consider. So D is equal to, suppose determinant 2, 3, 4, 5. So that is 10 minus 12. So minus 2 is coming. Now D dash determinant. So if we interchange any two rows or any two columns. Now here two rows and two columns, so you will interchange rows. So that is the second row will take at first place and first row at the second place. So by R1 2 which is interchange R1 and R2. So this value will get 4 into 3, 12 minus 10, so 2 is coming. So here the value is negative, but if you interchange any two rows, the value is coming positive. So D dash is equal to, we get minus D, or D is equal to minus D dash. D is equal to minus D dash. Therefore, determinant 2, 3, 4, 5 we can write minus determinant 4, 5, 2, 3. Now we understood third property. If any two rows or columns of determinant are identical, if any two rows or columns of determinant are identical, then value of determinant is 0. The value of determinant is 0. So, for example, suppose if you consider D is equal to determinant 90, 65, 70, 10, 11, 12, 90, 65 and 70. Now here, so when we go to the expanding, very much time is required. But if we observe this R1 and R3, so these are identical. So since R1 equal to R3, therefore D equal to 0. The value of determinant is 0. And then we will study this fourth property. If we multiply determinant by non-zero scalar, then it is multiplied to elements of any one row or column. You multiply that non-zero scalar to the elements of any one row or any one column. So D is equal to, suppose if we consider determinant A1 B1 C1, A2 B2 C2, A3 B3 C3. Now K into D, so K is a non-zero scalar, we are multiplying to determinant, so we get K into determinant A1 B1 C1, A2 B2 C2, A3 B3 C3. So that is equal to, if you take this inside, you multiply to any one row or any one column. So we can write KA1, that will be multiplied to the first column, KA2, KA3, B1, B2, B3, C1, C2, C3. Now here K is common in the first, so we can take that outside also. So K into A1, B1, C1, A2, B2, C2, A3, B3, C3. That is, in determinant, we can take common outside. We can take common outside from any one row or column. So here we are taking K common outside from C1, from C1. Now next pick the property. So if determinant is like this, A1, B1, C1, A2 plus X, B2 plus Y, C2 plus Z, A3, B3, C3. So we can write that is equal to determinant A1, B1, C1, A2, B2, C2, A3, B3, C3 plus determinant A1, B1, C1, X, Y, Z, A3, B3, C3. So this property states that if any one row or any one column is the addition of two elements, we can write addition of two determinants. Then next property, sixth property, if we multiply non-zero scalar to any one row or column and that product is added or subtracted to corresponding elements of other row or maybe column, value of determinant not changed. Not change. So D is equal to, suppose A1, B1, C1, A2, B2, C2, A3, B3, C3. Now if we multiply non-zero scalar to any one row, suppose we multiply to this. So by R3 plus K into R1. So you multiply K to the first row elements and that product will add to the corresponding elements of third row. So D is equal to, will get A1, B1, C1, A2, B2, C2. Now here A3 plus KA1, A3 plus KA1, B3 plus KB1, C3 plus K, C1. So that is equal. Now by previous property, this property, as here third row R3 is the addition of two elements, we write addition of two determinants and K is the common again we get. So A1 B1 C1, A2 B2 C2, A3 B3 C3 plus K common we will take from third row and A1 B1 C1, A2 B2 C2, A1 B1 and C1. Now here A1 B, so that this value is 0, K into 0, since R1 is equal to here R3, and therefore D is equal to determinant A1 B1 C1, A2 B2 C2, A3 B3 C3. And seventh property, determinant, this seventh property, value of determinant is equal to sum of products of elements of any one row or column and their cofactors. So we can expand the determinant in terms of the elements of any one row or any one column, and we'll take the sum of the products of that element and its cofactor. We'll get the value. So determinant can be expanded in terms of elements of any one row or any one column. So that we already studied in the minors and cofactor previous video. So okay, now without expanding, you want to find the value of this determinant. So solution, let D is equal to determinant to 10, 13, 16, 30, 33, 36, 47, 50, 53. Now without expanding means by using the properties, you want to find the value of this determinant. So here, suppose if you do the operation by C2 minus C1 and C3 minus C1 D is equal to, we get determinant. So 10, 30, 47. Now second column minus first column. So 30 minus 10, 3. 33 minus 33, 50 minus 47, 3. 16 minus 10, 6. 36 minus 30 is a 6. 53 minus 47, 6. Now we will take common outside from C2 and C3. We will take common from C2 and C3. So D is equal to 3 into 6 into determinant. So 10, 1, 1, 30, 1, 1, 47, 1, 1. So that is equal to 18. Now this value of this determinant is 0. Why? Because C2 is equal to C3. So you know the property. If any two rows or any two columns identical, value is 0. So that is equal to 0. So in this way, we can solve the examples by using the properties of determinant. So keep these 7 properties in the mind and practice the examples by using the properties. This article is useful again in the matrices. When we study matrices, we compare the matrices with determinant. At that time, the properties are required. And also to find adjoint etc. of the matrix, minor cofactors is required. So thank you very much.